Welcome to Mission Control. I am your flight director for today's explainer, and if you are prepping for the Cambridge AS and A-Level Mathematics 9709 exams, you are exactly where you need to be. Today, we are cracking open the examiner's playbook and treating this exam paper like a highly complex flight system that requires absolute perfect execution. Our prime objective: mastering differential equations using initial conditions. Now, on the central console screen, let me introduce you to two flight candidates we've been tracking. We've got pilot Alex. Alex tends to overcomplicate data calculations, burning way too much time and exam fuel. And then we have pilot Sam. Sam is the opposite. Sam ignores structural boundary constraints, skips the constant of integration, and risks a total systemic breakdown. Today, we aren't just going to look at the math, we are going to lock on to the pre-launch telemetry and get straight into how the examiners, your ground control, actually think so you don't make the same mistakes our pilots do. Let's initiate launch sequence.
Here is the flight plan on the main HUD. 1. Core principles. 2. The method mark strategy. 3. Solving systematically. And 4. Top examiner warnings. Trajectory locked. Let's move.
Phase 1. Core principles. The foundations of 9709. Let's clear orbit. Listen up, crew. The stakes on this mission are absolute. Look at the quote on the main display from the principal examiner. This topic appears in every examination series. There is zero chance we bypass this in orbit. It's not some obscure anomaly or a minor syllabus point you can skim over the night before. Mastering this guarantees a return on your study fuel because it will absolutely 100% be on your paper. If you don't prep for this, you crash, period.
Tracking the approach trajectory now. When ground control grades your differential equation responses, they are treating command keywords as system parameters and targeting three distinct cognitive domains. First up, knowledge and understanding. Do you actually know the foundational calculus rules? Second, application. This is where pilot Sam usually fails, ignoring boundary constraints and forgetting to substitute x equals 0 and y equals 5 to find that constant. And third, analysis. Pilot Alex struggles hard here, overcomplicating the algebra and burning time instead of structuring reasoning logically. Examiners prioritize deep analytical depth over superficial breadth. They want to see a methodical flight path.
Now here is a massive tactical insight pulled right from the principal examiner reports. The theoretical architecture of differential equations doesn't just float out there in a vacuum. It heavily relies on integration with other syllabus areas. The telemetry shows us that candidates who actively reference cross-topic connections, say linking their differential equations back to integration techniques or kinematics, like velocity and acceleration, score significantly higher marks. It's literally like linking your secondary propulsion systems directly to your navigation console. Show ground control you understand how all the interlocking pieces of the 9709 system fit together.
Initiating Phase 2, the method mark strategy, earning points for process. Let's keep scanning.
This brings us to our core fuel efficiency protocol, the method mark strategy. Look, ground control awards marks for your systematic process and your analytical framework, not just for miraculously stumbling upon the correct final landing coordinates. They are actively watching your high-tech UI console for a logical, step-by-step progression. If you make a tiny arithmetic error right at touchdown, but your calculus and application of initial conditions were structurally perfect, you are still capturing the vast majority of the payload points. Sam, stop ignoring the structural constraints and rushing to the final answer. You have to show the flight path to get the points.
Moving to Phase 3, solving systematically, the 5-step framework. It's time to optimize this trajectory.
Okay, hold on, pause the simulation. Flight director overriding the console. Before we fire the secondary boosters to secure maximum marks and dive into this framework, you need to optimize your own flight path. Subscribe to Ace the Exams at the handle @AceTheExams right now and turn on all notifications so you never miss a mission update. Okay, resuming simulation. Our pilots just encountered a critical roadblock mid-paragraph where their evidence links totally failed. To save the trajectory, I am injecting this 5-step structural template directly into the system. First, deconstruct the question. What are the actual command parameters? Second, extract relevant data. Pull out those exact initial conditions. Third, select your analytical framework, like separation of variables. Fourth, execute with clear notation. Show every single step of your integration on both sides so ground control can track you. And fifth, present your final answer with professional mathematical terminology.
Look at the radar comparison between standard candidates and elite ones. The standard candidate, kind of like Pilot Sam, offers superficial breadth and generic rushed answers. But the top-scoring candidate, they operate on a completely different frequency. They actively demonstrate an evaluative mindset. They question system assumptions, they justify their navigational decisions with hard mathematical evidence, and they tie everything back to the specific context of the mission. This evaluative, fully justified approach is exactly what clears the highest grade boundaries.
All right, we are engaging the Interactive Viewer Radar Challenge. I have live audience tracking active right now. I'm putting a 60-second visual countdown clock on your internal HUD. Scan the data in your mind and answer me this. Do you know the #1 reason students lose marks when dealing with initial conditions? Search the grid. I'll give you a hint. It's almost never a failure to understand basic calculus. The reality is debris on the track that is entirely avoidable. Have you spotted it?
Entering our final phase, top examiner warnings. Don't lose easy marks. Keep your shields up. Initiating debris detection sequence. Here are the top 3 systemic breakdowns that cause a crash on this paper. Number 1. Confusing cause and effect. This means misinterpreting the system parameters, failing to establish which variable is dependent and which is independent. Number 2. Forgetting to check format and presentation. We're talking sloppy notation, skipping steps to save time like Pilot Alex does, or the absolute deadliest system failure of all, forgetting your constant of integration, plus C, before applying your initial conditions. That's an instant trajectory failure. And number 3. Providing generic answers that completely ignore the specific mission parameters.
Warning alarms are flashing on the console. Examiner alert. This is the hidden core variable you must locate on your radar. Always link every mathematical point back to the given scenario. Ground control has literally issued alerts about this classic mistake. If the differential equation models the cooling of a liquid or a bacterial population growth, your final answer and your constants absolutely must reflect that physical reality. A mathematical model is just useless code if it doesn't solve the real-world problem presented on the prompt. Do not leave orbit without your context.
To build a foolproof safety net against those examiner warnings, rely on this deconstruct, solve, evaluate loop as your final approach vector. Identify the given info, break it into logical steps, solve systematically, showing all working, check your answer for reasonableness, like does a negative population even make sense in this reality, and finally make justified recommendations. Think of this diagnostic loop as your final check to ensure Pilot Sam hasn't ignored constraints and Pilot Alex hasn't burned all the exam fuel overcomplicating the system.
Here is your final pre-flight checklist preparation. To lock this entire procedural framework into your system memory, use a highly actionable memory hack for your study sessions. Create a mnemonic using the first letters of the key terms. For deconstruct, extract, select, execute, and present, you could use DESEP. Create a phrase that wires perfectly into your own neural network. When you are sitting in that exam hall and the pressure is peaking, write that mnemonic at the top of your scratch paper to instantly calibrate your radar back to the perfect strategy.
Mission accomplished, crew. Touchdown sequence confirmed with full marks. But before we fully power down the central console, I want to leave you with this. What hidden assumptions are holding back your analytical process? Are you rushing the trajectory to just get an answer, or are you securing every single method mark along the flight path? Remember your pre-flight question scan checklist. Now your final directive. Subscribe to AC Exams at the handle @ACExams, enable that notification bell, and drop a comment below sharing your specific subject and tier. Keep your telemetry sharp, trust the system, and I'll see you in the next explainer.